Hello and welcome to the Take Charge podcast. Hieu Duong, the Chief Manufacturing Officer of AM Batteries, joins me to discuss their dry battery electrode manufacturing process, comparing it to his experience of Maxwell Technologies and Tesla post-acquisition. We acknowledge their recent 30 million Series B funding round and what this means for the business, whilst talking through the various opportunities dry process manufacturing presents in the United States. As well as reduced costs, increased efficiency and environmental benefits, this process presents an opportunity for manufacturing talent across the US to more easily transition into battery manufacturing versus the conventional wet coating method. This could be a huge solution in being able to adequately staff our upcoming gigafactories. The solution might be dry, but the subject certainly isn't. I'm very excited to witness the future of battery manufacturing, and Hieu does a great job offering context in this episode. Hieu, let's take charge. Hi, Hieu. Welcome to the show.
Yes, hello, Jamie. How are you?
I'm good, thank you. How are you?
Excellent, excellent. Thank you.
Good. I appreciate you coming on today. I'm really excited to talk about dry powder manufacturing and the process associated to that. It's a hot topic right now. So before we get into that, I know you only joined around 6 months ago, 8 months ago. So how has that gone to this point, and what inspired you to join AM Batteries in the first place?
Yeah, so first off, Jamie, it's great to be on your show, of course. I'm excited to share our Dry 2.0 electrocoating technology with you and your viewer. And thank you again for providing this awesome platform for AMB to share our story. So my first several months at AM Battery is super exciting and productive. I joined AM Battery because I have the opportunity to advance Dry 2.0, so pushing the limit of dry electrode manufacturing that is near and dear to me. So my passion has always been in early stage technology development and industrialization, and so I'm pumped to be part of the AMB team.
Nice, good stuff. And before we get into the your dry powder process at A and B, let's start with your history, because of course you were with Maxwell prior to the
Yep.
acquisition and stayed with them. So yeah, talk us through your personal history all the way through to the present day.
Yeah, absolutely. Thank you. So I was academically trained in organic chemistry. And my entry into the battery space started with the development of membrane and separation technology. So, if you understand membrane and separation technology is no different than a separator in between the two electrodes in a cell, right? So that led me to composite separator development for silver zinc aqueous battery, recyclable, rechargeable, I should say, silver zinc battery. And then from there, I moved into lithium ion battery development. And ultimately, in 2011, I was hired by Maxwell to adapt their dry coating technology from ultracapacitor into the lithium ion battery space. Okay, so we took it from, coating activated carbon to all the, great chemistry in the lithium ion battery space. And then fast forward to 2019, after the Tesla acquisition, I had the pleasure to stay on and help scale the process alongside brilliant engineers. And what a fantastic time and learning for me.
Great. And then taking a deeper dive into your dry powder process at A and B, um, of course, you were a big part of that during the time with Maxwell and Tesla. How does it differentiate from that process?
Yeah, so at AMB, our philosophy is that we believe we can squeeze more benefit out of the dry coating. So two principal metric that we hit on is lower cost and even higher electrical performance, right? And this is through three key areas. The first is process step reduction. The second is particle engineering, and the third is electro architecture. So let me just quickly highlight the key feature for you there. So if I walk you through the process at the very front end, the AM battery dry powder mixing cycle time is on the order of minutes. So very quick, right? So once we mix the formulation, we coat this powder, this free flowing dry powder, directly onto a foil. And then we follow up by a calendaring step and rewind. and that's it. That's the end of the electrode manufacturing. So dry mixing, spray coating, calendar, done. So the electrode is ready for cell assembly. And because we're coating with the free flowing powder, any coating that is out of spec in the front end, we can recapture the active material, which for cathode is super expensive, via a vacuum, right? And so we recapture via vacuum, reuse without remixing. So this is key. We do not have to put this material back into our mixer and remix. So because it's in particle form. So why is this important, right? So it's super advantageous in coating line startup. So if you're starting up a coating line, especially in the wet process, whatever you coat onto the foil, and if it's not within spec, that becomes scrap. In the A and B process, you coat until you hit your specification. Anything that's out of spec, you can vacuum up because it's dry powder, dry particle. And you basically cycle that back in the front end and recoat, right? So our yield is super high in terms of loss is next to nothing, right? Until you're satisfied. In
Amazing.
general, our electrode density is highly tunable, right? And we can readily press these electrode anywhere between 3.6 and 3.8 grams per cc. So this is super important to boost cell energy density where everybody is pushing toward, right? How do we pack more energy into a cell? And we can offer that via the dry process because we can densify the electrode pretty readily. The other advantage we bring, not only the density of the electrode, but because of our electrode formulation and dry coating, we yield an electrode with more open pores and higher surface energy. So why is this important, right? So this is some of the benefit we don't capture up front, but in the back end in cell manufacturing, because our electrode wet a lot quicker when you're injecting electrolyte, when you're filling your cell with electrolyte to complete the assembly, it's a faster process. So therefore, your downstream cell manufacturing throughput is much higher because we're doing the dry process upfront. Okay, and our electrode formulation is comprised of commonly used material in the wet coating space, except of course for the liquid part, right? And hence the cell performance is typically equal to or better than that of a wet coated electrode. And so you can see together these advantages allow us to capture additional value in the dry coating space.
Brilliant. I mean, my next question was going to be what are the benefits versus wet processing, but you've
Yeah,
answered a lot of those questions there.
yeah. But I can
Yeah,
I can throw those in as well. Sorry, we haven't talked about cost, so I can add that
sure.
if you want me to. I mean, you know, on the cost side, right? So typically in general, when you talk about dry versus wet, right? There's three area, right? There's cost savings, electrical performance, and of course you have the sustainability piece, right? In terms of cost saving, there are three pieces to this, right? At the front end, the CapEx were about 30% less than traditional wet coating equipment. Okay. On the energy usage to produce the electrode were 45% less. And in the manufacturing floor space, we're about 75% less than that of the wet coating. Remember, we're getting rid of this huge oven in between and all the solvent management system associated with managing that or coating wet, if you will. We're getting rid of that, right? So so getting rid of solvent and reducing the electricity usage is a huge push toward sustainability, and of course that translate to cost. The other piece we haven't talked about is with the dry process, it helped to future proof your process for material that is liquid sensitive, right? So if you're a believer in solid state battery, for example, right, it's super hard to coat wet, right? You need like highly dense electrode. The solid state electrolyte is quite sensitive. So here we're doing everything dry, right? And like I said earlier, in our process, because the powder is free flowing, we can press it to a very high density in our coating process. So
Brilliant.
sorry to jump in there. I just wanted to capture the other benefit. There's a lot, of course. So
No, definitely, and environmental as well. I know there's huge
Oh,
environmental benefits
absolutely.
on top
Just
of the
getting
costs.
rid of that NMP piece, right, is tremendous. I mean, like, just working with these hazardous chemical. I mean, at this day and age, I mean, who wants to work with them, right? If we can bring that benefit, I mean, that alone is a huge progress over just traditional wet coating alone.
Definitely. Um,
Yeah.
and of course, huge benefits. We can, of course, cut the three stages. I think it's a four-step process instead of seven. But then when looking at dry powder processing, what are the major risks or the major challenges that you have to overcome?
Yeah, so thank you for pointing out the process cut. So those three process step, as you noted, or are solvent drying, solvent recycling, and of course the electrode vacuum drying. So I just want to quickly touch on those pieces real quick. I think the drying piece and the solvent recovery we mentioned earlier. On the electrode vacuum drying piece, again, this is one of the benefit in downstream that we don't talk about, right? Because we don't expose our material to any liquid and we manufacture the electrode under dry room condition, we don't see a need to vacuum dry the electrode before cell assembly because that's a time consuming energy intensive step as well, right? You make these rolls of electrode and then you stick it in the oven, you vacuum dry it overnight or whatever specified time, that's going to be, some cost associated with that, right? But if we're processing it dry, you don't have to do that step. You can take the electrode and produce yourself. And so back to your question regarding the remaining, or the main challenges, right? And obviously that's scaling, right? Getting it to be bigger, faster, and better, and building the ecosystem around dry electrode manufacturing. So as you know, AMB business model is to sell turnkey coding solution, okay? And we'll work with you to transfer that process know-how to coat your material.
You mentioned a good point there, that the challenge in terms of scaling, which is a huge challenge across all the US, whether it be dry or wet process.
Mhm.
There's a huge talk around the US versus China when it comes to manufacturing, and of course, China is way far advanced. Does this give the US more an advantage? Does it bring more challenges to scale US versus China? What's your opinion on that?
Yeah, I think it certainly bring advantage to the U.S., right? So as in anything, technology help drive some of the competitiveness in any field, right? So we see in the U.S., in order to maintain that leadership around dry coating technology, we have to be strategic with our investment and the commitment to sustainable energy infrastructure, right? As you know, it takes hard work and patience to achieve profitable mass production scale battery manufacturing. I mean, this is hard stuff, right? And I think we will get there faster with advanced technology, right? That's the way we compete pretty much in all industry, right? Through advancement in technology.
Definitely. And
Absolutely.
and and before we get into manufacturing in general across the US, it'd be good to understand a bit more on anode versus cathode, and where
Yeah.
you see the biggest opportunity and challenges when it comes to dry process.
Yeah, another reason we're focusing on cathode is a preemptively set the stage for this, onset of solid state battery, right? So if we're talking to a solid state partner, they of course will want solid state. So working with the cathode allow us to, be more flexible with what we can bring into our company in terms of advancement in the dry coating development. That's not to say there's no advantage on the anode side. There's a lot of advantages as well on the anode side, right? As you know, as we advance the material side to higher specific capacity material by adding silicon or what have you out there, stuff that we don't know of, it require us to coat thinner electrode. And in the AM battery process, we coat from bottom up. So we deposit dry powder from thin to thick. So it allows us to capture that value as well to get the thin electrode. We can do thick, great, but on the thin side, we need to capture that as higher capacity material becomes available to us.
Very good. And before the conversation, I was very interested to talk about the personnel side of things in the US. Of course, it's a huge talking point. When all these gigafactories are built, who's gonna run them? Who's gonna scale these pilot lines into mass scale? And I've been doing a lot of reading and spoken to quite a lot of people. There aren't many, and just from working in the industry, there aren't
Mhm.
many process engineers with that wet coating experience. Is it true that this dry process would allow us to bring engineers and process engineers in from different and peripheral markets?
Yeah, absolutely. I mean, like with the dry, you're not tied to that liquid-based manufacturing process, right? So it allow us the opportunity to leverage other industry manufacturing fundamental and know-how to contribute to this cutting-edge electro process technology, and of course, the advanced manufacturing equipment. So we can use folks from the paper industry, for example, cement industry, tire compounding and processing, anything that basically work with dry powder processing, mixing up front and translating that into a finished good or product. We can use mechanical engineer, materials engineer, chemist, physicist, you name it.
Wow. I guess even like
Yeah.
food as well, the food industry.
Absolutely. Food, beauty product, for example, pharmaceutical, right? Just in like tablet type processing, pressing, any type, like I said, powder manufacturing. Yeah. Yeah.
Wow. And
Tremendous opportunity.
yeah, definitely. And I mean, let's say, for example, Hugh, you were interviewing somebody from a different industry. How would you convince them to come and join the battery charge?
Yeah, absolutely. I mean, like, we offer career advancement and fulfillment in driving, societal impact, right? With dry electrocoating, as we noted earlier, focusing on decarbonization, sustainability, environmental impact, and all that great stuff. It's their chance to contribute to a mega trend, if you will, right? And for me, it's to be relevant, to establish foundational leadership as a first mover in this, fastest one in one of the fastest growing industry as we know it today, right? So, retooling and contributing what they know to this brand new field.
It's
Exciting time.
it's a question I get asked a lot about from clients. Is do you have any advice on where we should house our next Gigafactory based on talent in the area? And each client is
Mm,
is never really too sure on where to go, and there's always the common issue: there isn't much talent to pick from in terms of battery talent that they're going to kind of house their Gigafactories with. So
sure.
in this instance, it kind of gives you much more options. So it's exciting to see
Absolutely.
how how this will change the manufacturing landscape across the US. Um,
Yeah.
moving the conversation slightly onto your future, AM batteries, and congratulations again on the recent funding, the Series B funding, 30 million,
Thank you.
led by Toyota Ventures. And I saw the timing of that; it was towards the back end of last year, end of 2023.
It was, yeah,
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 so,
yeah.
so not
Sometime in the back end.
not too long after you joined, I guess. So maybe the investors saw you join and they
Yeah,
saw the
not
potential.
Yeah, not too long. I got lucky, I guess. I wish I could claim all the credit, but I leave it to our co-founder and our CEO. They were the one who drove you know, the funding. So yeah,
You're being modest. I think you had a big part to play in that. But no,
thank
it's
you.
obviously a huge milestone to hit. What does that mean to the business, and how does the immediate future look for you?
Oh man, my God, super bright, right? We're fortunate to be in this highly exciting manufacturing space, right? With tremendous market pull. I mean, this is truly a case where you built it and they will come scenario, right? The advantages of our dry coating technology really sells itself, right? It's a state of the art technology at low capex and opex. I mean, like, it's win-win all around, right? uh, yeah, it's a wonderful place to be at the moment.
Great. And then in terms of the future, I'm sure we'll get into the challenges shortly. But what are you most excited about post funding that
Yeah,
you're kind of over the next 12 to 24 months?
yeah. I think the proliferation of dry electrode manufacturing and building out, the dry ecosystem is the most exciting part for me, right? To see this thing goes live into Gigafactory and to see, product coming out the back end, using, something that's beneficial, like so benefiting, like this process technology. Yeah, this is super exciting.
Great. And what are you most concerned about? What do you see as your challenges over the next, or biggest challenge over the next 12, 24 months?
Yeah, it's stuff that maybe I don't really have control over, right? Our macroeconomic environment, geopolitical conflict, perhaps leading to investment headwind, if you will. We have great momentum on the development and technology side, and the market pull from, transitioning to sustainable energy, and everybody's driving hard. You and I and everyone heard of so many gigafactory being built all around the world, right? So this onset of excitement. So lots of momentum there, but some of the stuff that we don't have control over, as I mentioned, is the macroeconomic environment and the geopolitical stuff.
Good. Well, if you're not worried about many things that are in your control, I guess that's a good sign. You know,
Oh,
I've
absolutely.
always I've always I've always been taught to worry about the things that are in your control. You don't worry
I
too much about
totally agree.
what isn't. Make contingencies, of course, but try not to worry about those things
Yes,
that you can't
yes,
make an impact
yes.
on. Um,
It help you plan better for the future.
for sure. Um, Going back to your past, actually, talking about the future, let's go back to the past. What was the biggest lesson that you learned from your time with Maxwell and Tesla, and through that acquisition that you'll then use during your time with AM batteries?
Yeah. So what I learned is that building a world-class team is so critical to success, especially for advancing a disruptive technology like the dry coating, right? So we look for a complementary skill set outside of the battery industry, as we talked earlier, from other industry to leverage, the talent pool there and their know-how and some of the innovation that they brought to those industry to help scale it, right? They're more advanced and more mature than electrode manufacturing, especially in the US. So we want to pull those folks into the company and build that team. We have an awesome team already as a foundation, where we launch the technology with, and now we're looking to grow that, right? And we can't bring in people fast enough. Like I said earlier, there's a lot of interest in our technology from, major OEM, cell manufacturer, equipment manufacturer, and even material supplier all over the world, wanting to talk to us, wanting to collaborate. So, we're setting the stage to, you know, bring on to onboard those excitement and those opportunities. And of course, we can't do it alone. So we need people. But as you know, hiring is not easy, right? And getting people up to speed, right? They come in with a skill set, and now we have to train and instill some of the trade secret and the process know-how to these folks, and so they can couple that with their fundamental background, and help us succeed.
Great, good stuff. Um,
Yeah.
and I mean, you've moved to the right place. So Massachusetts is there's a real density of talent there. So a good strategic move there from the business. So exciting times ahead, and good luck for that journey. If you were able to give your younger self some advice as you're about to embark on your career, knowing what you know now, what would you say to that
Yeah,
person?
absolutely. I would say, don't worry, be happy.
It'll all work out in the
Yeah,
end.
absolutely. Yeah, it would definitely work out at the end.
Great.
Mm.
Good stuff. And in 10 years' time, as a kind of closing tradition, I would like to ask kind of how you feel the battery world would look in 10 years, but let's make that specific to battery manufacturing. How do you think battery manufacturing will look in 10 years, specifically in the United States?
Yeah, hopefully lots of dry manufacturing, of course. I mean, as a factory turns over their service life on their current wet coating, we like to see folks consider, and we know folks are considering dry electrode manufacturing. So we want to be ready for that, to time that market and the onset of new gigafactories. So we love to be part of that ride, and be incorporated into those gigafactory within the next 10 years. Absolutely.
Nice. Very good. Um, I'm excited to see how this develops because a huge conversation right now is talent. Well, the lack of talent in the US, who's going to house all these gigafactories, and I'm speaking to a lot of clients across the US who are just struggling for certain skills, and they're just not
Mm.
present in the US. Where we take they're kind of asking me to see if I can find somebody from China or South Korea to kind of move them over, and it's not sustainable. So I think this
Okay.
process you have and this method, it allows individuals from different industries to move into the battery space because there's a lot of interest from individuals in different
Mm.
industries who want to move into batteries because it's super exciting. There's a lot of movement, there's a lot of investment, and this is that pathway for them because when it comes to wet process, they just can't make that transition. It's too much of a gap. But in this case, in dry process with powder handling, there's much more potential there. So let's hope that your hypothesis is true in 10 years time.
Yeah, hopefully, yeah, 100% on your comment on the wet coating piece. I mean, I've been to mixing equipment vendor facility, and even the folks who are making mixer. And usually, when manufacture equipment, they do an on-site, factory acceptance test, and those folks who have to run the test with solvent, they want to move away from solvent because they don't want to deal with it, right? You have to suit up and like in a spacesuit, and the toxicity that's associated with working with and managing that solvent alone is such a nightmare. So we're happy to offer this unique dry electrode manufacturing process for folks for technician around the world.
Great. I mean, the capex savings, the environmental impact, the time benefits. I'm excited to see how this progresses. So, wish you the best of luck on this journey. It sounds like a very
Thank you.
exciting and a very busy time ahead for you post funding. So good luck with that. If anybody wanted to get in touch with you and learn more about AM batteries, where should we direct them?
Yeah, I would recommend the folks to go to our website. So it's am-batteries.com. We have a HR team now with job posting. And so please, check in there. If not, I mean, you can hit me up directly. I will provide Jamie my contact information, and then, we will bring you in and hope to have you on board.
Definitely. Yeah, we can post the website link on these comments, um and yeah, of course, people can get in
Fantastic.
touch with you and your team. But Hugh, thank you so much
Awesome.
for coming on the show. Since we announced this, I think it was the back end of 23. I was very excited to welcome you on. So yeah, I appreciate you sharing your insight on dry process and hopefully the future of battery manufacturing in the US.
Yes, thank you so much for providing this forum again for us, Jamie. Super appreciative of your work, and yeah, hope to be on again soon.
For sure.
Thank you.
Definitely. Thank you, Hugh. Good luck.